Hey guys, we're going to talk about the last quadrilateral today, and that's the trapezoid. Trapezoid is not a parallelogram. A parallelogram has two pairs of parallel sides. The trapezoid only has one pair of parallel sides, and those parallel sides are called the bases. So we'll label this base 1, second one base 2. The other two sides are called the legs. In a regular trapezoid, those are not congruent. The third thing that we need to talk about is called the midsegment. That hits at the midpoint of the legs on each side. And again, since they're not congruent, we would not use the same marking on the legs. To find that midsegment length, you find the average of the bases. So base 1 plus base 2 divided by 2 to find that length. Those are basically the properties of a regular trapezoid. Then we have an isosceles trapezoid. It adds on a few more. You still have one pair of parallel sides, and those are the bases, and again that's marked with an arrowhead. So base 1 and base 2. But instead of the legs not being congruent, in an isosceles trapezoid, the legs are congruent. And that's marked here with a hash marking. The third property is that we can still find the midsegment by finding the average of the bases. The fourth property deals with the diagonals, so I'm going to highlight those for you. The diagonals are congruent in an isosceles trapezoid. Now they don't bisect, and you can tell that visually, but they are the same length across the shape. And the fifth thing has to do with angles. The base angles for the first base and the second base are congruent. So here, this entire angle is congruent to the other angle, and these two top angles are congruent. You also know that since it's a quadrilateral, the consecutive angles are supplementary, so they equal 180. So let's look at some examples. In the top row, you have regular trapezoids, and we will use the fact that the consecutive angles are supplementary in the first one. So I'm going to add these two together and set them equal to 180. So that gives me 25x plus 3 and 2 is 5 equals 180. I'm going to subtract 5, that gives me 175, divide by 25, and that gives me x equals 7. In the second example, we're given two values for the bases. So this would be base 1 and base 2. And we're given the length of the midsegment. So to set up an algebra equation, I need to add the bases together and divide by 2. So that would be 8x, 6 and negative 2 is 4. Divide by 2 and set it equal to the midsegment length. Now because 8 and 4 are even, I'm going to go ahead and divide those by 2. So 4x plus 2. If they were not even, you could multiply 2 to the other side. But in this case, I can divide. So now I subtract 4x, that gives me 1x, add 3 to the other side, and that gives me x equals 5. So a simple algebra equation. You're going to use the same process with example 3. You're given two bases, and we want to add them together and find the average of the two, so that means add and divide by 2, and that gives you x. So that would be 56 divided by 2, which is 28. And last on that row, again, you're going back to angles and knowing that consecutive angles equal 180. Now I'm going to work this one a little bit differently. Instead of adding those two together, I'm actually going to just figure out how much is left for this bottom angle. So you can do that by taking 180, subtracting 128. That leaves you with 52. And then set that 7x plus 17 equation equal to 52. Subtract 17, that gives you 7x equals 35. Divide by 7, x equals 5. On to the second row. Here we are given isosceles trapezoids, so we know the base angles are congruent, we know the diagonals are congruent, and the legs are congruent. So we're going to start off being given some angles. So EDO, this angle here, the entire thing is 110. Then you're given, switch colors for you, that DEN which would be this angle, is 15x minus 5. So once again, we know that these consecutive angles are supplementary, so 110 subtracted from 180 leaves me with 70 for the 15x minus 5 base angle. So I can set 15x equal to 70 plus 5 would be 75, divide by 15, x equals 5. Okay, moving on, now we are given some diagonal lengths. So P to R is 3x minus 7. And T to A, that entire diagonal, is 20. So because I know as a property that the diagonals are congruent, I can set 3x minus 7 equal to 20. So add 7, 27 divided by 3, x equals 9. Quick and easy. Alright, now in the next example you're given a whole bunch of different lengths and you have to know which ones are congruent. Remember that the 15 and the 19 represent the bases, and the 2x minus 18 and the 10 represent the legs. Those are marked as congruent. Those are the two we said equal. So 2x minus 18 equals 10. Add 18. Divide 28 by 2. 14 is your answer. And last but not least, we're going to use the property to find the mid-segment length. And that's by averaging the two bases. So 20 plus 12 divided by 2, average of the bases, should equal the length of the mid-segment, 2x plus 6. So that's 32 divided by 2 is 16. Subtract 6, divide by 2, x equals 5. That's the trapezoid.